This is muriatic acid, and you can do a lot of cool things with it. You can use it to etch concrete, to clean out your pool, or to dissolve your phone if you really wanted to. But today, I'm just going to try to measure its concentration. For those of you who failed chemistry, muriatic acid is also known as hydrochloric acid. It's made up of a hydrogen atom bonded to a chlorine atom like this. It's a super strong acid because it dissociates entirely into ions when mixed with water. Most often, this acid comes in a solution mixed with water where its concentration is given in the percent by weight. For example, a bottle labeled 30% hydrochloric acid would contain 30 grams of HCl for every 70 grams of water. Typically, when someone sells you a deadly chemical like muriatic acid, they will do you the courtesy of telling you its concentration. However, when I went to the safety data sheet of this muriatic acid, it listed the concentration could be anywhere between 10 and 30%. They also stated that they will not disclose the true concentration of the acid as it is a trade secret. Now, for most average Joes buying this acid from Home Depot to clean out their pool, knowing the exact concentration probably doesn't matter. But to an at-home amateur chemist like me, it most certainly does. The most common way of calculating the concentration of an unknown solution is to perform a titration. But to be honest, I really didn't feel like doing a titration because it was both long and kind of triggered my PTSD. So instead, I brainstormed a few other ways of determining the concentration of my muriatic acid, and I came up with the following. The first idea was just to stick my pH meter in the solution. Now, this seemed like a pretty good idea at first, until I realized that my pH meter was giving me a pH of 5 in distilled water, so that was out of the picture. The second method was for me to just smell the solution and use my innate chemistry sense to deduce the concentration. Honestly, this seemed like a pretty solid idea until I remembered that I had lost my sense of smell when I had COVID a while back and it still hadn't returned. So then I thought, well, if I can't smell it myself, why can't I just get my little brother to smell it for me? Unfortunately, there was a small obstacle preventing me from doing this, and that was my dad and his belt. So in the end, I did have to settle with the titration. The way that titrations work is that you take a known volume of your sample, which is called the analyte, and add an indicator to it. Then you incrementally add small volumes of a titrant, which is a solution of known concentration of a compound that will react with your analyte. In my case, the analyte was my solution of muriatic acid, and the titrant I would be using was sodium hydroxide, which is a base that will react with the acid in a 1-to-1 ratio. Once the moles of titrant added is equal to the moles of analyte initially in the solution, the indicator changes color and you stop the titration. So now the first step to doing my titration was to measure out a specific volume of the muriatic acid. Now, unfortunately for me, I didn't have a graduated cylinder, which is what a chemist would use to measure a specific volume of a liquid. So I started looking on Amazon for some that I could buy, but right at that moment, I got an idea. When I was younger, my mom used to tell me a story of a time her car ran out of gas on her way to college. She got stuck on the side of the road and a kind man pulled over and gave her some gas. He used some sort of tube and sucked out the gas from a container, then blew it into my mom's car. I could do the same thing to measure out volumes of hydrochloric acid. All I had to do was use a PVC pipe to suck up the acid sample and dispense it into a beaker. The PVC pipe had a fixed length and diameter, so I could easily calculate the volume inside it. But alas, safety is my #1 priority, and using a PVC pipe to measure acid this way just wasn't very safe. So I went with a straw instead of a PVC pipe. It was easier to use anyway. Once I had measured out a specific volume of hydrochloric acid, I needed to make my titrant. To do this, I measured out 12 grams of sodium hydroxide and mixed it with 100 milliliters of distilled water to create a 3-molar solution of NaOH. I made sure to add base to water and to add it slowly while mixing to prevent the solution from heating up too much. Now all I needed was an indicator for my titration. The most common indicator is phenolphthalein, which turns pink upon reacting with a base. But purchasing phenolphthalein would require removing money from my already suffering college fund, and I wasn't willing to do that. So instead, I decided to go with a cheaper indicator that was readily available at home. My tongue. You see, the human tongue is full of something called taste buds, which are great at picking up tastes. My reasoning, therefore, was pretty simple. The reaction taking place involved an acid, HCl, and a base, NaOH. Acids taste sour, so as long as the solution was still sour, I would just keep adding the titrant NaOH. The final products of the reaction between HCl and NaOH are just water and sodium chloride, meaning that around pH 7, when the titration is complete, the solution should just taste like salt water. So in the end, after performing the titration and doing all of the calculations, I got a concentration of about 27% HCl by weight, which is actually pretty good. I bought this gallon of acid for about $12, and buying the same amount from a legit chemical company could cost me anywhere between $70 and $300. Granted, I don't really know the purity of this acid, and the SDS sheet, as I described before, was rather lacking, but I still consider it a pretty good deal. This video is not sponsored, but if you're considering buying department store muriatic acid, Clean Strip Green, it's pretty decent. Thanks for watching this video. If you'd like to see how I actually did my titration, click right here or on the link in the description of this video where I describe in greater detail how I actually performed the titration. And if you don't care, well, you should, because I spent a lot of time on this.